In this video, I'm going to talk about even and odd functions. So a function f of x is even if when you substitute negative x into the function as an input, your output is going to be positive f of x. So you put in negative x and out comes f of x. A function is odd if when you substitute negative x into the function, you get negative f of x as output. So a function is either even, odd, or neither. It cannot be both even and odd at the same time. Let me do some examples. I have 10 functions here, and I'm going to show you how we can determine if the function is even, odd, or neither. So all I do is I substitute negative x into my function. So here, f of negative x is equal to negative x squared. I'm just replacing x with negative x. This is a square function, so instead of squaring x, I'm squaring negative x. Now, when you square a negative, it's the same as a positive. So this is actually equal to x squared, and that is exactly my original function. So if you substitute negative x and get out your original function, then the function is even. Now here in the next example, I do exactly the same thing. This time I'm replacing x with negative x, so that becomes negative 3 times negative x. Well, a double negative is positive, so this is going to be 3x. And 3x is the opposite sign of my original function, which is negative 3x. So 3x is equal to minus f of x. And when you substitute negative x and get minus f of x, that means your function is odd. Okay? Here I'm going to plug in negative x into the original function. This, of course, becomes 3x plus 2. Now, 3x plus 2 is not the opposite sign of negative x plus 2. I'm sorry, negative 3x plus 2. The reason is the 2 did not change sign. So, nor did we get our original function. So this function is neither the original or the negative of the original. So this function is neither even or odd. Here we have a cube function. Plugging in negative x into our function, we have negative x cubed. And because the exponent is odd, we keep the sign. This is the opposite sign of my original function. And so this function is odd. In the square root function, we plug in negative x. Now, this gives me the square root of negative x. And this cannot be simplified, okay? So this is neither even or odd. In fact, if you think about it, the domains completely change. Here the domain is all positive x values. Here it's all negative x values. So including 0. Now, with an odd index that I have here, I replace x with negative x, but since I'm taking the cube root, I can pull that negative out front because of the index is odd. And so this is an odd function. So I meant to put in negative x. Now plugging in negative x for this function here, I have 3 times negative x to the 4th power minus 5 times negative x squared plus 7. And when I simplify these, because these are even exponents, the negatives are going to go away and I get the original function. Okay, so this is even, because this function here is identical to my original. So plugging in a negative x gives me the same as f of x. So it's even. Now here, plugging in minus x, because these exponents are odd, this is understood to be a 1, right? Because these exponents are odd, I can pull those negatives out. And so I have 2 times negative x cubed minus negative x. This is going to be negative 2x cubed plus, because of the double negative, plus x. And this is exactly the opposite sign of my original function. So this is minus f of x. And so my function is odd. Now, it's not going to work, even though these exponents here, notice that the function is almost the same. The problem is this constant is going to throw things off, just like this constant up here. This function was odd, but adding that constant made it to become neither. So when I plug in negative x for this function right here, I'm going to get the opposite sign for the first term, the opposite sign for the second, but the constant is going to stay the same, and therefore this function is neither. In this example, our last example, f of minus x is 1 over minus x, and I can pull that negative out front, so I get the negative of my original function, so that means our function is odd. I hope these examples helped you with understanding what it means for a function to be even and odd. And in another video, I'm going to talk about symmetry of a function, which is related to these two concepts.